Living in a world dictated by invisible algorithms can feel like navigating a storm. We are surrounded by fast-moving data and black box systems that appear to make decisions in a vacuum. When reality becomes this confusing, the solution is to practice first principles thinking. We strip the problem down to its most basic, undeniable truths, rather than trying to match the world's frantic pace. We often fear artificial intelligence because we view it as magic. When we examine the foundations, however, we find a logical structure built carefully from the ground up. Human intelligence began with the simple act of observation. A farmer would watch the patterns of seeds growing, or a traveler would note the specific angle of a shadow to find their way home. This observation transitions into data the moment we assign a number to that physical reality. Whether we are measuring height, weight, or time, the number allows us to compare one thing to another.
Artificial intelligence stands on this deeply human drive to quantify and compare the world around us. Every modern daily action, the time you wake up, the route you travel, the specific song you skip, is recorded as a measurable number. These numbers gain meaning when they are placed into directional space. In the language of AI, we call this a vector, a way to represent information as a specific point in a coordinate system. These spatial arrows allow a system to map physical traits into an abstract grid. By placing measurements onto axes, a machine can see how different data points relate to one another. This chart shows that transformation in practice. The physical dimensions of these three people are mapped directly as points A, B, and C, allowing the system to see their relationships mathematically. Organizing thousands of these vectors together creates a matrix. This structure acts as an engine, processing and transforming massive amounts of human data simultaneously. An AI's ability to think is essentially the geometric organization and transformation of our measured reality. Because AI relies on mathematical prediction, it inevitably faces uncertainty. When the world changes, the machine's initial predictions are often incorrect. Optimization is the process of learning from those mistakes. The system measures the exact distance of its error and uses that data to adjust its internal settings. This creates a rigid feedback loop. The model will try, inspect the result, adjust for the error, and test again. Over time, this cycle continuously shrinks the gap between the prediction and the truth. Machine learning functions as a mechanical system of persistence, using this disciplined cycle of repair to reach its goal. Modern AI has moved beyond single, isolated models. Today's most advanced systems are built through massive scale and cooperation. This complexity relies on specialized models called agents. These models are designed to hand off specific tasks and contexts to one another, mirroring a professional team. Intelligence emerges when these agents operate as a collaborative network. Supervisors and review gates ensure the system remains accountable to evidence and logic. As these artificial systems grow in capability, they increasingly mimic human organizational structures, creating a layered environment that requires constant oversight. When we build systems that can collaborate and learn this effectively, we have to ask, what is the cost of letting them fully automate our lives? Consider an AI optimized solely for comfort. If a system observes you struggling with a difficult math problem or a complex route, its rule is to automate the friction away. It begins suggesting easier paths and familiar ideas to protect you from the distress of effort. But growth requires the very distress the system is programmed to eliminate. If every challenge is hidden and every risk is filtered out to keep things efficient, the environment required for imagination and persistence disappears. A system optimized only for comfort can leave a person in a state of developmental stagnation, protected from struggle, but also from the experiences that build human capability. This leads to the ultimate first principle. Absolute trust in a system's accuracy does not grant it the freedom to act. Technology extends our reach, but it cannot replace the lived context and care required to manage real-world consequences. We must remain the architects, the human conscience that sets the boundaries, demands proof, and retains the ultimate override over the machine. Artificial intelligence serves as a mathematical mirror of our own logic. It is a powerful reflection that we must continuously question and responsibly guide.